Hi, my name is Jan and I'm a chemistry student at Cardiff University. Welcome to a new series of videos in which we will cover some of the basic topics of catalysis. In this video we will explain what affects the rates of reactions and how catalysts work. Reacting chemicals together to make new materials requires very specific conditions. These can include temperature, pressure and more. Some reactions can take a long time because the conditions cannot be reached. We can change how quickly the reaction goes in several different ways, but it's all about increasing the rate of reaction, which is how quickly the product is formed. We measure the rate of reaction as how much product is formed per unit of time. Let us think about what happens on a very small molecular scale. When reactant molecules collide, they need a minimum energy for the reaction to be successful. We call this the activation energy. We can think of this like a cyclist riding up a hill. The activation energy is the vertical distance from the starting point to the height at the top of the hill. We have to have enough energy to cycle over the top of the hill. If we do not have enough energy to do this, the reaction will not be successful. A large part of chemistry is working on how to increase the rate of reaction. This can be done in a number of ways, and to understand this, we need to consider the movement of molecules. Firstly, we can increase the pressure or concentration of reactants. This increases the chance of a successful reaction due to the frequency of collisions between reactant molecules increasing, which means more collisions are happening. This increased frequency means that there are more collisions happening per second, so it is more likely some could overcome the activation energy, therefore increasing the rate of reaction. We can also increase the surface area of reactants. This allows more reactant molecules to be exposed to each other, increasing the chance of a successful collision, and again increasing the rate of reaction. These are very similar, so if we go back to our cyclist analogy, we can imagine them both as having more cyclists trying to get over the hill. There is a higher chance of some of them being successful. Increasing the temperature also increases the rate of reaction by increasing the kinetic energy of the reactant molecules. This is their movement energy. The molecules move around much faster at higher temperatures, and there will be more successful collisions between molecules as they will have more energy than the activation energy barrier. Imagine our cyclist is now pedaling faster, giving the bicycle more kinetic energy, and therefore may have a better chance of having enough energy to get over the hill successfully. Finally, we could use a catalyst to increase the rate of reaction. Catalysts allow chemicals that would normally require extreme reaction conditions or long reaction times to be produced rapidly and safely. Catalysts do this by providing an alternative route, allowing for the reactant molecules to have a lower kinetic energy and still react without itself being used directly in the reaction or changed at all. This alternative route will change the reaction to become more favourable towards forming the product. Looking back at our cyclist, they can take a route where the hill is a lot lower, making it a lot easier for them to complete their ride, so the activation energy is lowered. We can think of this as cycling from Brecon to Cardiff. Pen y Fan is the highest mountain in South Wales. It would take the cyclist a lot of energy to cycle up the 850 metre incline. However, the A470, the main road that runs between the two places, has a maximum height of around 440 metres. Taking this alternative route requires the cyclist to use a lot less energy and is the equivalent of using a catalyst in a chemical reaction. By lowering the activation energy of reactions, it means there will be more molecules that will have enough energy to overcome the energy barrier. This will mean the chance of a successful reaction increases, which will increase the rate of reaction and form the product much faster. Optimizing all of these factors to achieve better rates of reaction is cutting-edge work, and catalysis forms a huge part of the chemistry industry with billions of pounds. In this video, we covered how we can control the rate of reaction and how catalysts can be used to help. In the next video, we will cover the different types of catalysts. I look forward to seeing you next time. Goodbye.